This is going to be a quick video just to demonstrate a contour plot. I know some of you know how to do this, but others had questions about that. So I just want to do a quick demo. So the intuition here is that I'm going to set up a grid, right, of X points and Y points, and then just evaluate at all of these different points, like say in a matrix of points, and then plot the result, right? So X and Y might be my inputs, or X1, X2, and then I've got some function F that I'm evaluating along that space, and I'm going to plot that. And I'm also going to plot a second function that might be useful for a constraint. I just want to emphasize, again, for optimization purposes, this is not a generally useful tool. If your function is simple enough that you can plot, we don't really need optimization, right? You just plot it. But most of our optimization problems have many variables, right? Tens, hundreds, thousands of variables, and we can't plot it. But plotting is a very useful technique for learning, right? To visualize as we're using algorithms or we're developing algorithms to kind of visualize what's happening. So we often simplify to two-dimensional problems so we can kind of plot and see what's going on. So here I've set up a function. We'll just say this is my objective function. And it's got two inputs here. I'm just going to call them X and Y. And it's just a simple function here. I guess we could write it in our normal notation of an objective. We could say this is F, and then this would be X1 and X2. Okay, so however we want to do that. Okay, so I'm going to start over here, clear everything out. I want to create a grid of points in X and a grid of points in Y. So I'm just going to create some linear space points, say from -5 to 5. And then for Y, I'm going to go from, say, -6 to 6. This is just sort of arbitrary here. And then, I didn't define these yet, but I'm going to have some number of points in X and Y. I usually like to make these numbers different. And the reason why I do that is if I make them the same, it's an exact square, then I can flip the matrix, the transpose of it, on accident and be plotting the wrong thing. So if I intentionally make the dimensions different, then I will get an error if I put things in backwards. And so I'll know, oh, I just need to transpose it. Okay, so I always make these different. Okay, so now, there's ways we can do it in vectorized. I'm just going to do it in a simple for loop here. So I'm going to initialize F to be of size nx by ny. You could do ny by nx. This is, there are some performance implications, but for something this small, it doesn't matter. Okay, so I'm going to call my objective at a bunch of points, xi, yj, right? So I'm going to go through every I, and for each I, I'm going to go through each j. So I'm just going to traverse my way across this entire grid of points, calling my objective, and I'm going to save it as an entry in this matrix here, F. Okay, that's really it. So now I just create a figure. I'm going to use the contour command. There are other options you could use. Use contour. And that is it. Okay, and so it gave me an error, which is actually great because it says, okay, the size of X must match the size of Z or the number of columns of Z. And the size of Z is F, 200 by 199, but the length of X is 200. So it's saying this should match this one. So you can see I've swapped them. So I could have either defined F as ny by nx and switched J and I, or I can just transpose it right here. And again, this is why I do this or why I make these numbers different, because if they were the same, it would have plotted it, but it would have been wrong. Like my X's and Y's would have been messed up and I would have been confused. So all I do here, I'm just going to transpose it and there it is. I'd like to have more contour levels. By default, it only shows like 10 or something. So I'm going to say I want 50 levels. I'm going to add a color bar. And I'm going to put some labels on my axes. In this case, they're just boring X and Y, but normally they would mean something more interesting. So there it is. See, I've got this color bar that's telling me the magnitude of these contours, right? What these correspond to. All right, so there's my contour plot. And let's say this is an objective function. Now let's say I wanted to plot a constraint as well. It's mostly the same process, but with one little wrinkle here. So I'm just make up a constraint. Look up what I made up previously. So that. Call this G. We'll call this a constraint. And let's do x squared plus y, something simple like that. Okay, just a simple function here. And I'm going to initialize G, same area. I'm going to compute it everywhere. And I'm just going to call the constraint function. So all of that looks the same. The main difference here, though, is that I don't want to plot the constraint at a whole bunch of points. That doesn't really make sense. I want to plot the constraint at a specific point, right? So say it equals 0 or it equals some number. Let's just say 3. So let's say I was plotting the constraint x squared plus y squared is less than or equal to 3, for example. Okay, or sorry, x squared plus y. Messed up here. I changed my notation. X1 squared plus x2 is less than or equal to 3. So I want to plot it only at 3. I don't want to plot it at all these other levels. That doesn't really show me my boundary of my constraint. So I do the same thing here, except for instead of saying 50 for the levels, I put the value that I want to plot at. And I have to put it twice, because if I put it once, it'll use it like the same way as this syntax, and it'll just plot 3 contours sort of evenly spaced. That's not what I want. You can give it specific levels to plot at, so I can give it a vector of as many things as I want, but if I repeat the same one, it's only going to plot it at 3. Since I'm doing 2 plots, I got to turn on hold so I can overlay them. And there it is, right? There's my contour, and then this is my constraint line. I could do some things to make it maybe look better. I could change the color. Say, let's make it black, for example. I could even make it thicker if I wanted to. Let's just make it a little thicker, 2 instead of 1. And so there it is, right? There's my constraint. And depending on if it was less than or greater than, right, I could maybe shade one of these sides or whatever. But that's really all there is to it. And that's good for this video.